These are the notes for the Go in 6.7. In the Go of 6.7, you're asked to find the slope between the pairs of points and then the distance between those 2 points. So both of these tasks you've done before, but we're going to just sort of make sure that we are all clear on how to do these. So it may be very helpful in this case to graph these 2 points just to get a sense of what is happening. So yx, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So over 1, up 5, over -3, down -3. So 1, 5, -3, -3. Now that I've graphed it, I can count the slope. However, it might be nice to just review the formula for slope. So the formula for slope is the change in y over the change in x, which is y2 minus y1 all over x2 minus x1. In our case here, we'll use the 5, 1 as our first point. So 5 is the y, minus -3 is my y of my second point, 1 is my x of my first, and minus -3 of my second, which gets me 8 over 4, which reduces to be 2. So in this case, my slope is 2. Now, it's really important to kind of go back and remember that, when I'm finding the distance, I'm really asking for this length. And that distance is very much related to Pythagorean theorem. So I can draw in my right triangle. And then, although the slope of this line is 2, up 2 over 1, up 2 over 1, this length is not 2 and 1. This length is 8 and 4. And we can see that in the unsimplified version of our slope. So it's always good to go back to that unsimplified version. Otherwise, you're going to get the length of this little triangle with the up 2 over 1. So to find the distance, we know that the distance is Pythagorean theorem. So we have leg 1 squared plus leg 2 squared equals hypotenuse squared. In this case, we're given the 2 legs. So I have 8 squared plus 4 squared equals h squared. 64 plus 16 equals h squared. 80 equals h squared. I then take the square root of both sides, and I have that h equals the square root of 80.